Hello everyone! In this lesson, we are going to learn how to solve quadratic and cubic equations given their graphs. How can we use a graph to be able to solve this? In the graph, we have x squared minus x minus 20. In the equation, we also have x squared minus x minus 20. The only thing that is changed is that y has been replaced by 0. We are going to look at the graph where y is equal to 0 and read off the x values. The x at this point is minus 4 and the x at this point is 5. The solution to this is x is equal to minus 4 and x is equal to 5. The second equation is x squared minus x minus 30 is equal to 0. Notice that x squared minus x is the same. But we don't have minus 20, we have minus 30. In this case, our aim is to make one of the sides of the equation equal to x squared minus x minus 20. What can we do to the minus 30 to make it into minus 20? If we add 10 to both sides, we will have minus 20. Minus 30 plus 10 is minus 20. 0 plus 10 is equal to 10. If we now compare this with the given graph, we can see that x squared minus x minus 20 is the same. On the other side of the equation, we have 10. So in this situation, the y has been replaced by 10. So at that coordinate point, we know that the y is equal to 10. But we don't know what the x is. Same for the other side. At this point, we don't know what the x is, but we do know that the y is 10. All we have to do is go all the way down and find out what the corresponding x value is. And on the other side again, we can see that's a 6. The solution is x is equal to minus 5 and x is equal to 6. For point C, again, our aim is to do something to this equation given x squared minus x plus 30 is equal to 5 into an equation that has on one of the sides x squared minus x minus 20. The x squared minus x, they are already the same. The plus 30 needs to be changed. This will give us minus 45. The y has been replaced by minus 45. Minus 45 is outside of this range. Therefore, this equation doesn't have any solution. So our final solution is no solution. Next, x squared plus x equals 20. X squared is the same. However, plus x is not minus x. We will have to change that. Again, our aim is make this into an x squared minus x minus 20 equals to something. What can we add to 1x to make it into a negative x? We minus 2x from both sides. We also minus 20 from both sides. Will give us x squared minus x minus 20. On the other side, 20 minus 20 is 0. Minus 2x is minus 2x. This is our y. We need to draw a suitable equation to solve this. This equation is y equals minus 2x. This is the same logic when you're solving simultaneous equations. In a simultaneous equation, you would have given y equals x squared minus x minus 20 and y equals minus 2x. So let's draw the line y is equal to minus 2x. We will start by drawing the y-intercept, and then we have to draw a gradient of minus 2 as a fraction is minus 2 over 1 or minus 4 over 2 or any equivalent fraction that will give you a minus 2. From the y-intercept that we have already plotted, from 0, 0, we go 2 down, 1 across. Then continue the pattern, 2 down, 1 across, 2 down, 1 across. Let's draw this. Now that we have drawn our suitable graph, we need to find the points where these two cross. Because we need to solve these quadratic equations only for the x values, we're only going to read off the x values from these two crossings. One of the solutions is x equals minus 5, and the other solution is x is equal to 4. In question number 2, we're going to use our graph to solve these three cubic equations. Notice that for the first question, x cubed minus 4x squared plus x plus 6 is identical to what is given in the graph. The only thing that is changed is the y. We need to look at the points on the graph where y is equal to 0. Looks like this particular graph has 3 solutions, these 3 points. Let's compare point B. X cubed is the same, minus 4x squared is the same, and plus x is also the same. We are missing the plus 6. Our aim is to make this side identical to that of the graph. So we need a plus 6 there. We can now add 6 to both sides of the original equation, and that will give us an extra 6, and then minus 2 plus 6 is equal to 4. If we draw a line across y is equal to 4, we can see that there are 3 solutions because the line y is equal to 4 is crossing this cubic curve at 3 different points. I'm going to label this minus 0.55 approximately. The next point, x is equal to 1, and the third solution, it's about halfway between 3 and 4, slightly above half. I'm going to label this 3.55. Let's write our solutions down. X is minus 0.55, 1, and 3.55. And finally the last question. X cubed minus 4x squared is the same. 0.5x and plus 5 is not the same. Our aim is to make the x term 1x instead of 0.5x and make our number term a plus 6. Add half x to make it into 1x, add 1 to 5 to make it into a 6, and since we have added 1 to the left hand side, we have to do the same for the right hand side. This result will give us x cubed minus 4x squared plus 1x plus 6 equals half x plus 1. X cubed minus 4x squared plus x plus 6 is identical to the one given in the graph. Our y becomes half x plus 1. Now we must draw a suitable graph on top of the cubic graph and find the points where those two graphs intersect. The y-intercept is 1. We start by plotting that. The gradient is half. We go 1 up and 2 across. Draw a straight line across. We can label our graphs and find the x-axis of the points where they intersect. This looks like it's very close to minus 1, but it's slightly below it. So I'm going to label this as 0.95 approximately. The next point is about 1.5, and the last point is about 3.4.